And now, for example 3, we will use linear functions to solve problems. We have here a situation. It states that a chairlift starts 0.5 miles above the base of a mountain and travels up the mountain at a constant speed. Now, how far from the base of the mountain is the chairlift after 10 minutes? So we can take 2 information from that. And also on our right side, we have a picture with some information in it. It states that 0.5 miles from the base, which we got from our word problem, and also the chairlift travels 6 miles per hour and it takes 15 minutes to reach the top. So for this word problem, we will need to first formulate. That means writing a linear function to represent the distance that the chairlift travels from the base of the mountain. And we will also let t equals time in minutes. So what we need is the distance the chairlift travels. Now we are working with this rate right here. This is where we will get our rate of change. But the problem is asking for the time in minutes, and we have here 6 miles per hour. So we will need to convert the 6 miles per hour into minutes. And we do that by multiplying 1 hour over 60 minutes. This is how we will convert the hour, which equates to 60 minutes. Now, if we multiply across, we have 6 miles. Let me just write it. Or let me just move that down so that you guys can see it without having to go over the picture. Okay. 6 miles times 1 hour. And then an hour times 60 minutes is 60 minutes in an hour. With both the hours in the top and the bottom, we can say that it cancels each other out, because an hour divided by an hour is 1. And so we are now left behind with 6 miles over 60 minutes. And we can simplify this and say 6 divided by 60, or 1 mile over 10 minutes. And this was done by dividing 6 and dividing 6 in the bottom. 6 miles divided by 6 is 1 mile, and 60 minutes divided by 6 is 10 miles. That is the common denominator. Now 1 mile is divided by 10 minutes. That is in decimal form 0.1 miles per minute. And now if we go back in our formula, we have the distance the child travels, the chairlift travels, and then the rate of the chairlift times the time it takes for the travel. So time in minutes is t. And we also need to take account that the chairlift started 0.5 miles from the base. So that's kind of like our y-intercept. This is the plus sign, so 0.5. And then if we think of this as our function, linear function form, f of x equals mx plus b. We can just say that the distance the child travels is d of t equals the rate of change was 0.1 miles per minute, 0.1 times t plus 0.5. From this, we can simplify that further and just say d of t equals 0.1 t plus 0.5. And so we now have the linear function to represent the distance that the chairlift travels from the base of the mountain. And now we will compute. So the distance of the chairlift from the base of the mountain at any time is represented by the linear function d of t equals 0.1 t plus 0.5. Now the letter d was a mistake, and we can just ignore that part. But if we go back to our word problem, 0.5, if we go back to our problem, we are looking for how far from the base of the mountain is the chairlift after 10 minutes. So this is kind of like our x value or our x variable that we will need to input into our linear function. So when we input that 10 minutes, we will put that into our t variable. So d of 10 equals 0.1, 10, we plug in the 10 in t, plus 0.5. And 0.1 times 10 is 1, plus 0.5, this equals to 1.5. So d of 10 equals 1.5. Now we will need to interpret. We have here the distance in 10 minutes. Equates to the 1.5, which is the miles. So we can say that after 10 minutes, or maybe say in 10 minutes, the chairlift will travel up 1.5 miles up the mountainside or up the mountain. And after all of these three steps, when we formulate, compute, and interpret, we can now represent our linear function into our graph. So we have a blank coordinate graph on the right side of your paper, and we will need to determine our y-axis, our x-axis, and our y-axis. We can do this by looking at our input and output. So for our input, these were our x values, or x values. And in our linear function, this was t, the time traveled by the chairlift. And this was in minutes. As for the output, these are our y values, which was after inputting any variable in our t, and then we would end up with the distance. So kind of like the computing part. In the computing part, we had input of 10 minutes, and after computing that, we ended up with the 1.5 miles. So distance traveled in miles. The input goes into our x-axis because that was our x values. So we can label the x-axis time, which is minutes. And now it'll be a little hard to label the y-axis unless you turn the page over, and we can label that as distance, which is miles. Remember that our formula or linear function was d of t equals 0.1 t plus 0.5. We will also have to label the increments on which our x-axis and y-axis will go on. And for our x-axis, since we work with 10 minutes, we can go by twos. So 0, starting from 0, and then skip a line, 2, skip a line, 4, 6, 8, 10, and 12. It's not as eligible. And you guys can leave more space in between the label and the increments on your paper. So I will have to fix mine. I'll need to move that down. Say 2, 4, 6, 8, 10, and 12. Now as for the y-axis, since we have 1.5 miles, we will need to work with decimals. So we can leave here with, or skip a line again, and work with twos in decimals. So what I mean is that we skip a line and say this is 0.2, skip a line, 0.4, 0.6, 0.8, and 1.0, 1.2, 1.4, and by working with that, I just realized that we do not have 1.5 in this. So we could add an imaginary increment and just extend the graph. don't want extending the graph. 1.6. So this ends up as 1.5 in the middle of 1.4 and 1.6. Now when we look at our function, we can remember the slope-intercept form, which was y equals mx plus b. And when we graph the slope-intercept form, we always start with the y-intercept, which is 0.5 in our linear function. So find 0.5 on the y-axis because we are graphing the y-intercept, and it's right here, 0.5. And then the next step is to take 10 minutes and 1.5. That was after 10 minutes, chairlift traveled at 1.5 miles. So 10 is right here on the y-axis. We start with the x in our point. 10, and then you can draw a line up all the way, and we find 1.5. You can follow the dash lines, and where they meet is where that point will end up. And with these 2 points, we can finally draw a line through these two. And that is how we can represent our linear function into a graph. And this concludes our lesson for 3-2 linear functions.